Alright, so we are live right now. So, hello and welcome all of you. So, welcome back to this amazing platform of Tutee Learning. So, today we're going to discuss about another important series of lectures on straight lines, right? So, as we start with our new topic on straight line, and that is going to be on the topic of pairs of straight lines, right? Now, this pairs of straight line is quite an interesting topic and yet an useful topic if you are basically setting out to understand the conic sections, okay? So this particular topic is going to definitely help you to understand the basic fundamental regarding the development of conic sections, right? So throughout the discussion of this particular topic, we are going to indulge in the different theories and also we will try to understand and derive from the fundamental principles, right? So let's try to see all those things over here. Okay, so if I start with the discussion on the basic thing of pairs of straight line, you can imagine a pair of straight line is basically two straight line which is coming together. So it can be imagined as a combined equations of two pairs of straight line or two straight lines, right? So if I have two straight line equation and I just combine the equation, that is I just multiplied both the equations and I equal it to 0, then that is something which is called as the pair of straight line, right? Or their combined equation. Okay, so what I can imagine this is particular thing as, so let us say I have a one particular straight line which is basically, let us say, a1x plus b1y plus c1 is equals to 0. So this is my known straight line, right? And also I have another straight line whose equation is given as ax plus by plus c is equal to 0, right? So this is my two straight lines. Okay, so having this particular discussion of straight line, maybe like it can be a2, b2 and c2 as well, right? So if I want to write the combined equation, so if I want to write the combined equation of these lines, okay, if I want to write the combined equation of this particular lines, I can do it by simply taking the product of these two line equations, okay, by simply taking the product of these two lines equation, and that will be something as follows, like this, which is equals to 0, right? So this is called as the combined equation of lines, or what we also called as a pair of straight line, right? So what we can understand from here is that if I try to represent two equation of the line together as a one form of equation, where, and in doing so what I'm going to obtain is that I'm going to obtain a general expression in the second degree, right, or second order expression, right? Now why is the second order expression important, we'll try to understand as we move forward with the lecture, right? But for the time being, you can think a pair of straight line as we are writing two straight line and I'm combining the equation to find out the generalized expression in second order, right? So this is second order expression, right? Now in order to find the combined equation of two lines, try to make the RHS of these straight lines equal to 0 and then try to multiply both the lines. So what I've done over here is that in order to write the combined equation of line, I have made the RHS part to be 0, right? So that if you multiply, the right hand side still remains the equal to 0. Okay, so if I do this multiplication, I will generally obtain some terms which is of second degree term, and if I try to represent them, if I just try to represent them, so it is definitely going to look like some ax squared, or maybe let me take ax square, fine, it is fine, and then let us say we have some coefficient of x and y, that is 2h plus by square plus by square plus 2 times of let us say fy, or let us say fx, right? Let us say we have fx over here plus 2 times of gy plus some constant c is equal to 0. Okay, let us say this is what will be the equation that I will obtain if I just multiply, right? So I have taken up all the possible consideration, right? Okay, now there is also a specific reason for writing these two terms over here, right? 2f and 2g, and similarly 2h, right? Now I will explain about this particular thing once we move forward, and you will see that this is quite an interesting way to write the equation of the line, right? So now once we write down the equation of the combined equation of pair of straight lines, what we'll obtain is that we'll obtain some form of line like this. But what you have to also obtain is see that these two lines are meeting or having the point of intersection at some point, let us say that is some x comma y, right? So it is having some point of contact at x comma y, right? Or let us say this is my point of intersection. Okay, so this is my point of intersection x comma y, right? Now if I just transform and let us say I take two lines such that both the lines are passing through the origin. So in order to make this simplified expression to start with, let us first of all assume that we take two lines passing through the origin. Alright, so let us take two lines passing through the origin. We have seen that the equation of line passing through the origin can be simply given as y is equal to m1x and y is equal to m2x, right? So I can write like this. In a similar manner, now please note that we have to make the right hand side to be 0, right? So I can write this particular expression as y minus m2x equal to 0, and similarly this will be y minus m1x will be equal to 0, right? So this I will obtain, and therefore from here the combined equation of this pair of straight line will become y minus m1 times of x multiplied with y times of m2 times of x, right? Y multiplied with m2 times of x, and that should be equal to 0. So if I just carry out this particular algebra, what I will obtain is that I will obtain some terms like y square minus and plus m1 m2 x square, and then I will obtain some term like 2 times of m1 plus m2 times x of y is equals to 0. So this would be my general expression of the pair of straight line, right? So this would be my general combined equation of the pair of straight lines. Okay, right? So this is also called as the, so this form of expression where you see that the terms of first order or the terms like x to the power 1 or y to the power 1 or the constant is 0. Okay, there is no constant, no first order terms of x and y. Okay, so only we have the second order terms involving x and y. So this kind of expression is also known as homogeneous expression, right? So this kind of expression is also known as homogeneous expression. Okay, homogeneous expression or homogeneous equation. Okay, so this kind of expression or equation is known as an homogeneous equation. Alright, so an equation whose right hand side is 0 and in which the sum of all powers of x and y in every term is the same, such let us say n is the order, so that kind of expression is generally called as homogeneous expression, right? So this kind of expression is an homogeneous expression, right? So this is also the pair of straight line passing through the origin, right? So now there are two important things that we need to relate from here is that now if I try to relate it back to the our general equation of the straight line that is given as like this as follows. So we will have the general equation of line as ax square plus 2 times of xy plus b times of y square is equal to 0. That was our general form of the pair of straight line equation, right? Now please note that what I can do is that I can start to compare on both these equations because they are representing the same thing. So this, let us say this is equation number 1 and equation number 2 as follows. Now if I just equate both equation number 1 and 2, because equation number 1 and 2 are representing the same thing, so these are equivalent, right? So if I do that, but before I do the equivalence relation, I have to make this coefficient of y square as 1. So therefore I will reduce this particular equation and write something like right, and then I can compare both the equation, and then I can compare both the equation to obtain that my 2h upon b would be equal to m1 would be equals to 2 times of m1 plus m2 and with a negative sign, right? So from here this minus and 2 and 2 will cancel out, and ultimately I will obtain the value of m1 plus m2 as h upon minus of h upon b, right? So I will obtain the value of m1 plus m2 as minus of h upon b. In a similar manner, if I compare the x coefficient square, x square coefficient, I'm going to get m1 multiplied with m2, and that will be equal to a upon b, right? That will be equal to a upon b, right? So from here, I can, if I am given only this particular form of the pair of straight line equation, from here only, by having the knowledge of the roots of this particular equation, I can still formulate for a quadratic equation in terms of, maybe let us say we formulate a quadratic in terms of x upon y, right? So we can also formulate a quadratic equation in terms of x upon y, and then we can solve for the following result, right? So, or maybe the roots of this particular quadratic equation in x upon y is also going to remain the same thing or imply the same thing, right? So I hope this is clear to all of you. Okay, so I presume this particular thing is clear. Now another important thing is that, now why do we actually need to study the pair of straight line, right? So generally they won't directly give you, maybe it happens that as a sense of conic sections, we don't even know that if I give you just a second order expression or second order polynomial expression, you won't be directly able to tell me what kind of form of equation it is. Right, so we have to first of all identify that whether it is a pair of straight line or not, right? So if you have any general expression where you have understood that it is a pair of straight line, and from there if you want to find out the expression without even solving for the two separate equation of lines, or without even finding out the two equations or the two roots of that particular equation, right, even without doing that, we are still in a position to solve for the slopes as well, right? So using this particular relation, we can also find out some other important properties regarding this, that is called as the angle, or the angle that is between the line, angle between two lines, okay, angle between the two lines in pair of pairs of straight lines, okay. So angle between the pair of straight lines. So let us try to find out how we will obtain this particular angle between the pair of straight line, right? So again, let us first of all consider the homogeneous case, because if we know the result for the homogeneous case, it can be easily extrapolated for that of the non-homogeneous case as well, right? So again, we have this point of intersection of these two lines as origin. So this is my two lines, and I need to find out this particular angle theta, right? I need to find out this particular angle theta. So what will be known to me is that I will know the equation of the pair of straight line in this particular format, right? That is going to be equal to ax square plus 2 times of hxy plus by square is equals to 0. So that will be the general form of the pair of straight line equation that will be given to you, right? So if this particular form is given, you don't need to actually solve for both the straight lines, or to find out the roots of this particular equation in terms of y upon x to get the slopes. However, without even solving that, you can easily find out the angle between the straight line, and that can be done by few modification in the result. Because let us say if you assume this is m1 and this particular slope is m2, then that angle between these two lines can be easily formulated as so tan of theta would be mod of m1 minus m2 divided by 1 plus m1 m2, right, divided by 1 plus m1 m2, right? So if we know this particular result, from here also we can extrapolate and find out the following result, right? So what I'm going to do over here is that it's basically a bit of an algebraic jugglery. So I'm going to write m1 minus m2 as now, if you recall from the previous expression, we have known the result for this particular expression, right? We know the result for m1 plus m2, and we don't know the result for m1 into m2, right? So given that we know the result for this following expression, now just one more mistake I have done over here, please rectify. This should not be 2, okay, this is m1 plus m2 only, right? I thought it is m1 plus m1, so that was 2 times of m1, that's what I write, okay? So please correct this particular expression over here, it should be minus of m1 plus m2, so this should be 2 will be left out over here, right? Okay, so we have this two equation expression, that is m1 plus m2 is equal to minus of h upon b, and m1 plus m2 and m1 multiplied with m2 is equal to a upon b, right? So we have this particular equation or the result with us. Now from here, what I'm going to do is that I'm trying to represent this m1 minus m2 and in the following known terminologies, right? So what I'm going to do over here is that I'm going to write this particular expression m1 minus m2 as m1 plus m2 whole square minus 4 times of m1 m2 and take a square root of it right. Right. Now, in order to remove this mod over here, I will put a plus or minus and whole divided by the expression is 1 plus m1 m2, right? 1 plus m1 m2. Now, we already know the values of this m1 plus m2 and m1 m2. So, if I just put it back over here, I'm easily going to obtain the result for this expression, that is tan of theta. It is going to come out as, so this will be 4h square minus, so minus of 2h by b, then whole square of it. So it is going to be 4h square by b square minus 4 times of m1 m2 would be equal to just a upon b and have a square root of it, and then whole divided by 1 upon a plus b, whole divided by 1 upon a plus b, right? So with this particular result, tan of theta would be equals to, so from here I will obtain that, I can simplify this part and I can obtain the simple result as h square minus ab, and 2 times of that, and then we will have a plus b. Okay, then we will have an a plus b over here, right? So, and don't forget there is a plus or minus sign over here, and if I just want to remove this plus or minus sign, what I can do is that I can take back the modulus again, or get back the modulus thing. Okay, now we know that the square root result is always positive, so the modulus won't work in the numerator but it will work in the denominator. So the result could be simplified as square root of h square minus ab multiplied by 2 and divided by mod of a plus b. Okay, so this is going to be the simple result. So from here you can easily obtain the tan theta, right? So two important results that you need to also keep in mind, that if my lines are perpendicular, okay, if the lines, if my lines are perpendicular, to each other, that means my product of slope should be equal to minus of 1, right? And that can also be proved by, or maybe the tan of theta is 90 degrees, that means it will tend towards not defined quantity, and that is only happening when a plus b is equal to 0. So that is basically a is equals to minus of b, right? Or I can write a plus b is equal to 0. So when my coefficient of x square and y square is equals to 0, then I'm going to have the lines are perpendicular. And in a similar manner, I can also obtain another relation for lines are parallel, right? So I can also obtain a relation for parallel lines, right? So the condition for parallel lines is that theta would be equal to 0. So from here, what I can easily conclude is that then my h square should be equals to a times b. Okay, so h square should be equal to a times b. So if I have this following two results, I am in a position to solve any types of problems, right? Now, in a similar manner, we can also solve for, to find out the equation of the angle bisector, right? So for this homogeneous case also, we can also find out the pair of straight line which represent the angle bisector as well, right? But before that, I hope this particular part is clear to all of you. Just let me know in the live chat, is this part clear or not? Is this discussion clear? Pittu Chena Reddy wrote out. Tell me your doubt, Pittu. Tell me what is your doubt. Please tell me your doubt. Okay. Is this part clear? Alright. So let us now move forward towards understanding the concept of the angle bisector, right? Okay. So let us now go towards understanding the concept of angle bisector. So if we have this pair of straight line like this, let us say this is my equation of pair of straight line, right? So this is my equation of pair of straight line and I want to find out the angle bisector, right? So the angle bisector will be also 2 over here, so that can be formed as a pair of angle bisector. Pittu Chenna Reddy, m1 m2 equal to minus of 1. Yes, m1 m2 is equal to minus of 1 is for the perpendicular lines, right? We have already seen this. So m1 into m2 is equal to minus of 1. From here also we can obtain the condition, that is a upon b is equal to minus of 1, right? So that is also equal to a is equal to minus of b. That means a plus b is equal to 0. The same thing, right? Is this clear? Is this part clear to you now? Any questions? Is this part clear? Okay, so let us come back and we try to understand the following formulation for the angle bisector. So again, we have the equation of the line as y is equal to m1x and another line as y is equal to m2x, right? So from these two lines, we have already obtained this general pair of straight line, right? Now our task is to find out the equation of the angle bisector. So we have already seen that the angle bisector equation can be easily obtained by doing the study, that is the any point on the angle bisector is having the same perpendicular distance from the two lines, right? So that is going to be, the expression can be written something like this, right? Oh sorry, this should be m2 whole square, right? Okay, so we'll have, this is the equation of the both the angle bisector, right? So if I just take this both the equation and combine it and I multiply, then I'm easily going to get the required condition of the equation of the angle bisector, right? So if you do that particular part out and then you substitute for the value of m1 plus m2 and m1 into m2 as m1 into m2 is equal to a upon b and m1 plus m2 is equal to minus of 2h upon b. So if you put that and you carry out this few lines of algebra, you will see that you will end up getting a simplified expression for the pair of angle bisector will be coming out as x square minus y square divided by a minus b should be equals to xy upon h. Okay, so this will turn out to be the equation of the angle bisector. This will turn out to be the equation of the pair of angle bisector. Okay, pair of angle bisector. Okay, so this will turn out to be the equation of pair of angle bisector. Alright, I hope this is clear to all of you. I hope this part is clear. Please do let me know in the live chat, is this part clear or not? For parallel, m1 is equal to m2. Yes, Manbir Singh, you are correct. For parallel lines, m1 is equal to m2, right? So for parallel lines, m1 is equal to m2, and that particular condition is basically means that the angle between the line is 0 degree, right? That means we can also write that particular condition as h square is equal to ab, right? H square is equal to ab is coming from this particular condition. So please follow the lecture carefully, okay? So m1 m2 is a parallel lines condition is correct, but when we are discussing about only one straight line, right? But in this case, you are not given a equation of one straight line, you are basically given the equation of pair of straight line, right? Is it clear, Manveer Singh? So from here, if I just put theta is equal to 0 over here, that means this particular numerator should be equal to 0. So this numerator will be 0 when h square is equal to ab. And please note, this h square, this h, a and b are nothing but these are the pair of straight line equations. So what we have seen that when you multiply two equations of straight line, we obtain this particular equation, which is also called as the pair of straight line equation, and it is a second order homogeneous equation. Okay, so please follow the lecture carefully, okay, because I am pretty much clear in explaining all the basic concepts, right? Is this part clear to all of you? Don't worry, just keep on asking me doubts. That will actually help you to get your fundamental clears as well, right? So it is good that you actually ask doubts, right? All right. Any more questions? Any more questions, anyone? Okay, so if we have this following condition, now we can go on to understand now what happens if I have a non-homogeneous form of pair of straight lines, right? So it is not always true that I will always have my point of intersection of the two straight lines as the origin, right? I might also have the point of intersection of the two straight lines as any random point, right? So that is also called as a general equation of pair of straight line, right? So let us try to understand the condition for any second order second degree equation in x and y to be a straight line equation, right? So let us try to understand that if we have a second order conic equation, so any second order equation will be a straight line equation if and only if which of the following conditions will be satisfied. Let us try to see. So if we have a second degree equation, and let us see when this particular equation becomes a pair of straight lines, right? Or yeah, pair of straight lines, when this particular equation represent pair of straight lines. Okay, pair of straight lines. Okay, so let us try to write down the general second order degree equation. So we can write the second degree in equation in x and y as ax square plus 2 times of xy plus by square plus 2 times of fx plus 2 times of gy, or maybe I can write it as 2 times of gx. Let me follow the standard, right? So in the generally standard books, it is given as 2 times of gx plus 2 times of fy plus some constant c is equal to 0. So this is the general second degree equation. This is a second degree equation in x and y, right? Now please note, this will hold true only if a is not equal to 0, right? Otherwise it won't be a second, otherwise it will be a second order degree, but please note that if we need to have a to be non-zero, right? Okay, now why do we need to have a non-zero? Because we will solve the following equation and we'll come to know about it, right? So let us now try to decompose this particular equation in terms of a quadratic as x. Okay, so if I compose this equation as a quadratic in x, then I should have the terms like, so all the terms are x and x square, and remaining all the terms are basically written as constant. So all the terms containing only y and constant will be constant, right? So that is my idea over here, to make it as a basically a quadratic equation in x. Okay, so this is basically a quadratic equation in x. So now we already seen the formula for solving quadratic equation in x. So from here, if I apply the Siddharacharya formula, I'm going to get some result as plus minus of b plus or minus square root of b square minus 4ac divided by 2 times of a, right? So if I apply that particular formula or the Siddharacharya quadratic formula, so x would be equal to this particular expression. So I will get my x to be this following expression. And then whole divided by 2 times of a, right? So if I solve for this particular value, I will get an expression in x and y, which will be the two equation of my straight lines, right? So let us now, in order to solve this condition, and you will see that this particular equation will something come out to be, and now from here I will have two roots only and only if the discriminant is greater than 0, right? Or for real root, the discriminant should be greater than or equal to 0, right? So I will get the values of x when and only if the discriminant is greater than or equal to 0. But if the discriminant is less than 0, then I won't get I will get complex roots, right? So this complex roots has no meaning to us right now, right? So this particular condition will imply the condition of the condition of when I will have two equations of the straight lines. That is only when either my this discriminant is equals to 0, right? So if I have my discriminant to be 0, if I have that discriminant to be 0, because what I'm trying to explain you is that this particular equation, whatever the pair of straight line equation is given to me, let me write it as some equation I. Okay, so this first equation, if this particular equation I is going to represent two straight line, if the left hand side of the equation can be resolved into two linear factors, right? And that can be done only if I have the real roots, right? So only if I have real roots, this can be done, right? So this can occur in two different ways, that is either I can have discriminant to be equal to 0, therefore the expression under the square root should be a perfect square, right? Otherwise, no, now please note that if this particular expression is not a perfect square, we cannot take it as a two linear factors, right? So in order to resolve this into two linear factor, this particular expression should be a perfect square, right? So let us try to see that how I can make this particular blue term as a perfect square. Okay, so this particular term should be a perfect square in order to factorize as two linear sum or two linear factors, right? So it should be a perfect square. Okay, so it should be a perfect square. So let us try to see that when it will become a perfect square. So it will only become perfect square when 4 times of, so that also I can consider a quadratic equation over here, right? So this particular thing is a quadratic in y, right? So if I consider this particular thing as quadratic in y and I express for perfect square, then that particular quadratic should have the discriminant to be 0, right? So this particular quadratic in y should have the discriminant to be 0 in order to be that this particular expression, this blue expression, to be a perfect square. So therefore I will have this 4gh minus AF whole square of it should be equals to 4 times of H square minus AB times G square minus AC, right? So this will give me the condition, a standard condition, that is ABC plus 2 times of 2 times of FGH, and then minus of A times of AF square minus B times of BG square minus C times of H square, and this should be equal to 0, right? So if and only if I have this particular condition, that is from the given pair of straight line equation or maybe any general second degree equation which is representing any conics. So if I have this particular condition to exist or hold true, which can also be written as in terms of determinant as this way, and I will have the expression of F, no sorry, I will have the expression of G, F, and sorry, I'm sorry, I should first of all write H over here, H, then when G will come and then F will come, and the symmetric matrix, so it should be just this. So if this particular determinant is equal to 0, then only this is the condition for obtaining pair of straight lines. So from any secondary conics equation, to get a pair of straight line, to represent that particular thing as a pair of straight line, the only condition to follow is this particular condition. So if my general conic equation is following this particular condition, then I can conclude and say that this is the following pair of straight lines. I hope this is clear to all of you. I hope this particular discussion is clear. Right. So in today's class, we are basically going to discuss up till here, and in the following formulation, we are going to discuss about how to find out the point of intersection in case of any general pair of straight line equation. Right. So from any general straight line equation or pair of straight line equation, how can I find out this arbitrary point of intersection? Right. So that will be the next motto. So what we have learnt is that any secondary equation of conics is going to represent a pair of straight line. The condition is known to us, right? And also I have seen that the second degree equation can be a homogeneous equation, can be a non-homogeneous equation. So from the homogeneous equation, when it is going to be a pair of straight line, that condition is known to us. And for homogeneous, if it is a pair of straight line, it will pass through point 0, 0, right, or the origin. And from there we have seen how to find out the angle between two pair of straight lines, and also how to find out the equation of the pair of angle bisector of this pair of straight lines. So without even solving for the two separate equation or the two separate linear equation of lines, we can still generate the equation or the angle of between the two lines from the second degree equation, right? So I hope this particular discussion is clear to all of you. So maybe in the next class we are going to discuss about the point of intersection, and then following that we are also going to extrapolate the ideas of the angle between two straight lines or pair of straight line for any general case, right, or how the formula is modified. We are also going to discuss about that, and following that we are going to solve one more topic that is called as the heterogenization, okay, or homogenization, sorry, homogenization, right? So that is another basic generalized concept for any curve, and we are going to learn that particular part in the upcoming lecture, and with that we will be done with our straight line. So maybe in the next class, that is going to happen at 6:30 p.m. on this particular channel. So we are going to complete the entire portion of straight lines, and following that we will discuss some more previous year questions, and then we are going to start with our new chapter, that is going to be circle. Okay, I hope this particular discussion is clear to all of you. If you have any questions or any queries, you can leave that up in the comments. Maybe I will try to answer all of your questions and queries. And so with this, I assume you are able to understand it. If not, please reach out to us on the number that is given in the description box as well as on the live chat. Okay, so with this, thank you for your attention for watching this particular session, and I hope you all the best, and I hope to see you soon in our next lecture. Thank you and all the best.